All right, everybody. So what I want to do today is I want to pick up with the normal probability distribution that we were talking about on class on Thursday. So if you guys remember, I was talking about some iPhone talk times. Does that ring a bell to people? We were kind of, drawing, normal density curves and computing some probabilities. So we're going to do all that again today. So first things first, I want to go in the classroom. And you're going to need in class today, if you go to course content under the week 9 tab here, I posted this PowerPoint that I'm going to use for class this week. Excuse me. And then I also posted this file here. It's called the standard normal table. So you should have this out and you should at least download it and have it on your computer. And it looks kind of like this, It looks exactly like this. It's 2 pages and it looks like just a bunch of numbers on it. Okay. How many people had a chance to maybe even print this out before class? Did anybody have a chance to print it out? Or, well, at the very least, you should definitely have it downloaded right now, okay? One other thing too, I'm gonna grade your week 3 homework, or your week 3 homework, your homework number 3 right after class today. I'm gonna do it during my office hours this afternoon. So I'll get to your week 3 homework graded to you later today. But I've also posted your homework number 4, okay? This homework number 4 is due next Tuesday at 11:59 p.m. And again, please don't be late on this. A lot of people have been submitting stuff late recently, so don't be late on this. And it's actually just, let me click on it here. It's actually only 2 problems, and each problem has 3 parts to it. So it's really only 6 questions, and you'll actually be able to do it after class today. So I highly encourage you to, to work on it like right after class if you want. And then I can take questions on it next class if anybody has any questions. Also, just as a reminder, did people know that the college is closed next Tuesday for election day? Did people know that? Yeah, it's not just my class, like all the classes are. Okay. Everybody planning to go out and vote? Anybody vote already? Yeah, well, I hope you get a chance to go vote. I actually dropped off my ballot last night in a secure Dropbox. It was weird, very weird compared to how it normally is. So I usually love election day, going in and actually voting. I haven't missed an election since I turned 18. So I love it. I think it's good stuff. So just make sure you go vote, especially if the college is closed that day. Okay. I will also put a reminder about this next class too. Before I get started, okay, does anybody have any questions for me? No questions for me? Okay, so here's you're gonna notice a pattern with pretty much every topic from here on out. So what today's topic is going to be is I'm going to introduce this new distribution called the standard normal distribution. And then what I'm going to do is I'm going to show you how to solve problems by hand. And then next class on Thursday, what I'm going to do is I'm going to show you how to use your graphing calculator to solve them. Okay. We have our next, looking at our course syllabus real quick. Our next exam is scheduled for Thursday, 11/12, but I'm probably going to move this to the 17th, just to give us an extra day in these topics here, okay? But I'll make that announcement officially next class, just so you can see where we are. All right. So today's lecture is going to be more about the normal probability distribution. All right. So this is from last class. Okay. These exact slides are from last class. Okay. At the end of class, we described this thing called the normal density curve. Okay. And it looks like this bell-shaped distribution. All right. Do you guys remember? And then we also talked about, the uniform distribution. Do you guys remember that? We did this example about package coming from a UPS, something like that. Does that ring a bell? Okay. So for some people it does. Okay, good, good. So like we had this simple formula for the uniform distribution last class, and we saw that we related the key concept from last class was that we related area under the curve to probability. All right. And then I said, well, not too many real world examples follow this uniform distribution. So instead we have this normal distribution, or this bell-shaped curve. And I said the normal, but this was the PDF stood for probability density function. It was given as this crazy equation, right? And what we said is like, oh my God, this looks terrible to work with. So we're not going to work with it. Okay. So instead, is everybody okay if I move on? Yep. Give me 1 sec. I'll have a little bit more coffee while we're waiting here. It's definitely a big coffee day for me, unfortunately. Sorry about that. Are you okay, Tora, if I move on? Okay. So we said, look, we're not going to work with this formula anymore. Okay. It's just terrible. It looks too complicated. So what I did was I introduced these properties. Okay. The first one is the curve is symmetric about the mean. There's a single peak. Total area under the curve is 1. Like that's how we relate it to probability. Because the curve is symmetric, and centered at the mean, half the area is above the mean, half the area is below the mean. Just that the horizontal axis is asymptotes. And then the big thing that we're going to use first today here is this empirical rule. Okay. And basically what it says, all right, and this is important, is that 68% of the area falls from the mean minus a standard deviation to the mean plus a standard deviation. 95% from the mean minus 2 standard deviations to the mean plus 2 standard deviations. And then 99.7 from the mean minus 3 standard deviations to the mean plus 3 standard deviations. And then, do you guys remember we spent a lot of time talking about this picture here? And I think we were able to do one example last class. Just a little bit. Okay. All right, so today, to start class today, we're going to use this curve again today. All right, so I've got 2 examples in the slides today, but I only want to do one. So I'll let you guys pick, okay? Do you want to talk about commute times to WCC or time spent on social media daily? So commute times or social media? I'll let you guys pick the example today. Social media, all right. All right, I guess, I'm sure, yeah, you guys did all agree. Social media is toxic. I spend a lot of time, I spend more time than I like to admit on Facebook. Sure, we're all kind of, some people spend more on it. Some people spend less, but anyways, let's just do this example, okay? And the problem goes like this, all right? Suppose that the time spent on social media daily, all right, enough in the chat. Leave the social media alone, opinions alone. We're just going to go with it. Suppose that the time spent on social media daily by WCC students is normally distributed, okay? So that's a keyword you're going to look for these problems, okay? So whenever you see this normally distributed, it means follows the bell curve, okay? And you can use the properties from the class, from the previous slide. Okay, and that's really important. Another thing that's really important, when something's normally distributed, I'm going to tell you what the mean is. So what we're saying is that on average, students at WCC spend 2 hours a day on social media, or 120 minutes, and then it's a standard deviation of 30 minutes, okay? All right, just please note I made these numbers up, okay? I don't know what they really are, okay? So here's what we're going to do. We're going to select a student at random, all right? And we're just going to record their time spent on social media, okay? So before I talk to the student, okay, do I know how many minutes they spend on social media each day? Right, yeah, no. Okay, so it's a random outcome, okay? So what that means is it's a random variable, all right? So I'm going to define this variable here, all right? I'm going to let X, I'll actually write it out even though I have it typed, all right? This random variable X is going to be the time spent on social media by a randomly selected student. Okay, and here's what else we know. We know it's normally distributed. So what I can do is I can do X, and this squiggly line here means X follows or is approximately normally distributed. All right, and then I tell you the mean, it's 120 minutes. And then I'm also giving you the standard deviation, that's that sigma notation of 30 minutes. All right, I can't stress this enough. All these problems that we're going to do this class and next class, it's going to be normally distributed. You're going to be given a mean and you're going to be given a standard deviation. All right. Is everybody okay if I move on? Okay, no problem. And I apologize in advance. In a little bit, my son's going to wake up from his nap. So if you hear a screaming child in the background, that's on my end. All right, are you okay if I move on? Okay, good. All right, so I've got this random variable X here, okay? So here are a couple questions, all right? Is the random variable X a discrete or a continuous random variable? So basically what I'm asking is time. Is time a discrete or continuous variable? All right, thank you, Alyssa. Yep. Okay, so this X variable, it's a continuous random variable. right, so the next question is going to be sketch the density curve for the random variable x. Okay, so the density curve, since we know going back that it's normally distributed, okay, the density curve is that bell-shaped curve. All right, so what you're going to do is you're going to draw this normal distribution, this normal bell-shaped curve. Hey, that's a pretty good one. I drew a pretty good one today. Okay. The high point of the curve. Okay, I'm going to draw a dotted line down. This high point of the curve, all right, is going to occur at whatever the mean is. So the mean is 120 minutes. So I'm going to put 120 here. And then what I'm going to do is I'm going to count standard deviations. Okay, so just recall the mean was 120 and the standard deviation was 30. So I'm going to add a standard deviation. So 120 plus 30 gets me 150. I'm going to add another one, I get 180. I add another one, I get 210. And now what I'm going to do is I'm going to subtract standard deviations on the other side. I'm going to go 90, 60, 30. Okay. If you look at this, okay, and I'm going to go back a few slides real quick. Do you see how there's like numbers here? If you look back on this slide right here, I'm just replacing this mu minus 3 sigma, mu minus 2 sigma, mu minus sigma, mu plus sigma, mu plus 2 sigma, mu plus 3 sigma with actual numbers, okay? That's really what's going on here. All right, so that's just, what we're gonna do now is we're gonna use the properties of the normal curve, okay, to just answer some probability questions. All right, so here's the next question. So we got this randomly selected student. What is the probability that the time spent on social media daily by that student is more than 120 minutes? So it's the probability that that X, that time spent on social media by the student, is greater than 120 minutes. I'm just curious, does anybody think they know the answer to this? Nobody's got a guess? All right, so here's how I tackle these problems. First thing, I pause and rub my eyes. If I had the camera on, you'd see me doing that. What I do is I draw the density curve again, okay? So first thing you do is you write the probability statement. Next thing you're gonna do is you're gonna sketch density curve. And you're gonna shade in the area you're looking for. All right, so what I'm gonna do is I'm gonna replicate this. Here's 120, 150, 180, 210, 90, 60, and 30. So I want to just be greater than 120. So I want to be this red squiggly area here. Okay. Okay. Well, look, I want to find the area above the mean. So look back at the properties, okay? How much of the area under the curve is above the mean, is above 120? Tora's got it. It's half. So that means this area is the probability. And it's 1/2 or 0.50. Okay. Does this one make sense? Okay. Uh-oh. Did you guys hear him?
Yep.
I tried to tell you. To be fair, I gave you the warning. All right. He's okay. He always wakes up hungry. So. All right, let's try the next one. All right. All right, what is the probability that the time spent on social media, because he knows social media is toxic. That's funny. Okay. What is the probability the time spent on social media daily is less than 60 minutes? Okay. All right. So I wrote the probability statement there. Probability that X is less than 60. All right. So what I find helps me solve these problems, okay, is sketching these curves. All right, will really help you understand what you're looking for. Can you guys give me just 1 second? Is that okay? I just want to make sure he's not dying. Is that okay?
Mm-hmm.
I'll be right back. Give me 1 second. All right, sorry about that. Good news is he's alive. He's going to make it. Okay. Thank you for laughing at that. All right, so what I'm going to redo here, I've got the probability statement. I'm going to redraw the density curve, okay? So the density curve, it's centered at 120. All right, so I'm going to mark off the standard deviations again. 150, 180, 210, 90, 60, and 30. All right, so I want to be less than 60, okay? So here's 60, all right? Now, if I want to be less than 60, am I going to shade to the left or to the right of that vertical line there? Okay, yeah, I want everything to the left. And you're not going to stop at 30, okay, because you could actually be less than 30, okay, because you can be more than 3 standard deviations. So I'm going to keep going, all right? So I need to find this area. Does anybody have a suggestion about how I could do this? All right, well, let me ask you this. Okay. How much area is below the mean? How much area is below the mean? Let's start with that. Okay, yeah, let me start with this. I'll help lead you guys there. How much area is below the mean? From 120 all the way to the left. Okay, yep, 50%. So from here to here, the area is 0.50, okay? But do you notice how I don't care about this unshaded area right here? How many standard deviations is it to go from 120 down to 60? Okay, so look, here's what I'm gonna do. I'm gonna go back to my chart that I had. All right, to go from here to here is 1 standard deviation. How much area is that? What's this? Yep, no, how much area from the mean to here? This like turquoise shaded area where my mouse is. 34, okay, so let me go back. So this part right here from 90 to 120 is 0.34. Now to go from 90 to 60, that's from 1 standard deviation to 2. This is the area between 1 standard deviation and 2 below. How much is this right here? Yep, 0.135. So I don't care about this 0.34 and this 0.135, okay? So if I know 50% of the area is below, but I don't care about this one or this one, can anybody tell me how I could figure out what the red shaded area is? Well, if I don't care about it, I got to take it away. All right. And what is take away? Like what mathematical operator does that imply? Yeah. Yep. So it'd be 0.50 minus the 0.135 minus the 0.34, which I believe if you do this correctly, well, I'll even grab my calculator for this. So 0.50 minus 0.135 minus 0.34, you get 0.025. Does that make a little bit of sense? I got one yes. All right. Let's try another one, okay? So how did I get the 0.50? So half the total area under the curve is 1. Total area is 1. Because the curve is symmetric, that means half has to be below the mean and half has to be above the mean. That's just that's a property of the curve. Okay. All right, let's try this one. Okay. What is the probability the time spent on social media daily is less than 90 or more than 150? Okay, so it's the probability that the time spent is less than 90, so X is less than 90, or X is greater than 150. All right, let me ask you this. When you see the or statement, all right, inside a probability statement, okay, what does, I don't think it implies X for multiplication. What does it imply again? Starts with an A, I'll help you guys though. Yeah. So you're just gonna take the probability that X is less than 90 and you're gonna add to it the probability that X is greater than 150. Okay, so you have to find two different probabilities here, okay? So I'm gonna sketch the density curve again. So you're centered at 120. You're gonna add your standard deviations and subtract your standard deviations. So 150, 180, 210, 90, 60, and 30. All right, so I'm gonna go to 90. If I want to be less than 90, I'm gonna shade to the left. And then I want to be greater than 150. So I'm going to go to 150 and I'm going to shade to the right. All right. So let's start by finding less than 90. Can anybody offer me a suggestion on how to do this one? Well, how much area is below 120? Okay, I think you meant 0.50. Yeah, yep. All right, so all the area here. So to go from 120 to 90 is how many standard deviations? You're close, Tora. To go from 120 to 90 is one standard deviation, right? So let's go back and look at our chart. To go from the mean down to one standard deviation, 34% of the area is there, okay? Yes, thank you, Tora. Yep. Well, so I don't care about this 34%, so I got to take it away from the 50. So this part here is 0.50 minus 0.34. And now I need to add to it. It's actually the same thing on the other side. To go from 120 to 150 is one standard deviation. So it's that 0.34. And we know half the area is above the mean. So this red shaded tail area here is 0.50 minus 0.34. So this is 0.16 plus 0.16. And what do those two combine to? There you go. And that's our answer right there. All right, what do you guys think? Bad, not too bad, terrible?
Doable.
Doable. A little bit easier when there isn't a kid screaming in the background, maybe. All right, well, let me tell you this. This is actually not how we're going to solve the problems going forward, okay? I'm gonna actually show you a little bit different way, okay? So you actually don't need to have this chart memorized anymore or keep it handy, because it's just not how this stuff is done on a regular basis or how we'll do it going forward. All right, you guys okay if I move on? Okay. So to solve these problems going forward, there's going to be two ways we're going to do these problems from now on. The first way I'm going to show you is I'm going to show you by hand, and I'm going to teach you how to read a statistical table. It's very fun. And what I really love about the problems going forward is like, there's going to be like a process, and the process is always going to be do this first, do this second, do this third, and you're going to get the final answer, which I think is like something we appreciate more than like sketch the curve, shade in the area, like now go to the chart. So this method I'm going to show you is a little bit, I think, easier. And then on Thursday, what I'm going to do, and everyone I think will really appreciate this, is I'm going to show you how to use your graphing calculator to solve this stuff, okay? All right, so what I want to introduce or talk about next for about 15 minutes, and then we'll take a break, is what's called the standard normal distribution, okay? So I want to go back and do this example here, okay? And I think this is the exact problem we were doing last class, which I said, suppose talk time on the iPhone 10 is normally distributed with a mean of 20 hours and standard deviation of 5 hours. Does this ring a bell? Okay. Suppose an iPhone 10 is selected at random and its talk time is recorded. So we got this variable here. We let X be the talk time on a randomly selected iPhone 10. And now here's the problem I have, okay? And this is going to set up why we need this standard normal. What is the probability that the talk time on a randomly selected iPhone 10 is less than 18 hours? Okay. So it's the probability that X is less than 18 hours. Okay. So here's how we were solving this. I'm going to draw the normal density curve. Give me 1 second. All right, so now you're going to draw the normal curve. It's going to be centered at 20. All right, and you're going to add some standard deviations. You get 25, 30, 35. You're going to subtract. You're going to get 15, 10, and 5. What's the problem with the question that I asked? Does 18 fall on a nice standard deviation here? Okay, so it doesn't, right? Like it's like kind of like right here. Okay, here's 18. So the problem is when it doesn't fall on a nice standard deviation, and I'm going to go back a few slides. You can't use this chart anymore, okay? So how are we going to solve this? All right. Does that make sense? Like since it doesn't fall on a nice standard deviation, we can't use those properties. All right, so we're going to need a new method to do this. All right, and this is what we're going to spend the rest of class learning. All right. Is everybody okay if I go to the next slide? All right, so to do this, we're going to need this thing called the standard normal curve. All right, and whenever you hear the standard normal curve, all right, you're going to think of the letter or the variable z, okay? And it's actually going to be synonymous with z-scores. Does anybody remember when we were talking about z-scores before? We did like the example with the teacher income and test scores. Does that ring a bell a little bit? I got one yes. A little. Okay, it's okay. We're going to come back to it. All right, so the standard normal curve. What is it? In mathematics, what are the two easiest numbers you think to work with? Like what? Yeah, exactly. 0 and 1, the two easiest numbers. So the standard normal distribution, okay, is a normally distributed variable having means. So let me write this over here because it's incredibly important. It's a normal distribution. Okay, so it follows this bell-shaped curve. But it has the amazing property that this curve, the standard normal curve, has mean. Mu is equal to 0. And it has standard deviation sigma equal to 1. All right. What's also amazing about it then is that it has the same basic properties as the normal curve that we saw before. So all those properties, and I'm just going to go back real quick. all these properties here hold for the curve, for this standard normal curve. All right, so this is what the standard normal distribution looks like. All right, it's centered at 0. And then when I add standard deviations, I get 1, 2, 3. When I subtract standard deviations, I get -1, -2, -3. Okay? So first off, just does it make sense that any normal curve that has a mean of 0 and standard deviation of 1, we're just going to call the standard normal distribution. How about that? Is that okay for now? Okay, I got one yes. Everybody else probably put me on mute when they heard my son crying. My apologies for that, everybody. It's one of those things about having kids. I think, is it just me or does he cry like every time we have a class? Yeah. I'm pretty sure I'll probably get an email from the dean being like, Matt, we need to have a talk about your childcare. Yeah. All right. It's your class alarm. Yes. Okay. So how are we going to use this? All right. This concept of this standard normal curve. All right. So first off, you can do what's called standardize any normally distributed variable. So what's going to go on here is we can change any normally distributed variable X, okay, like iPhone talk time, okay, to a standard normal variable. Okay. All right, so the formula for this is a z-score formula. Okay, so just recall. What a z-score does is a z-score tells how far any variable is from the mean in terms of standard deviations. All right, so this is the formula for it. Okay, so the standardized version of any normally distributed variable X is you take that X value and you subtract the mean and you divide by the standard deviation. Okay, these z-scores follow the standard normal distribution. Okay, so this z-score, so whenever you see a z-score, what I'm getting at here is it's going to follow this bell curve right here that's centered at 0 and have a standard deviation of 1. Okay. Does it kind of feel like it's a little like what the heck is going on right now for a little bit? Like, even though we're not all in class together, I can kind of be like, this seems a little weird. You know what though? I promise you, as soon as we do one example of this, it's all going to make a ton of sense. Okay, I promise you. So let me just get through one last thing and then we'll get to our break, okay? So look, here's some great things about the standard normal distribution.
Professor?
Yeah.
Do you think you can go back the slide for a second so I can at least screenshot it real quick? I'm sorry.
That's okay. This one right here?
The other one that we were just on. Yes, that one. Sorry.
Okay. I can pause for a second.
No, that's okay. I got it. Thank you. Okay, I got it. Thank you.
Okay, no problem. Okay, so what's really amazing here is you can take any normal distribution, okay? Any normal distribution. This one here is mu -2, standard deviation 1. This red one here has mean 3, standard deviation 1/2. This normal curve here has mean 9, standard deviation of 2. And when you take the values of these standard deviation or of these normal curves and run them through the z-score formula, they always get transformed to the standard normal curve, right? So these z-scores transform any normally distributed variable to the standard normal curve. Okay. Why do we care is the next question. Like, okay, Matt, what use is this at all? All right. And so I'm going to use this slide here in this area here to illustrate this, okay? So what I want to draw here is I want to draw the iPhone distribution, iPhone talk time distribution. And right next to it, I want to draw the standard normal distribution. Okay, the iPhone talk time. Does anybody remember what I said the mean talk time was? How many hours? It was 20, yep. Does anybody remember what the standard deviation was? Okay, thanks. All right, so this is a bell curve. It's centered at 20. And I'm just going to do 2 standard deviations. Okay, I'll go to 25, I'll go to 30, I'll go to 15, I'll go to 10. Does anybody remember what the area between one standard deviation on each side of the normal curve was? So if I say, hey, you know, how much area is between 15 and 25? Let me go back to the thing for you, okay? So from one standard deviation below to one above, how much is it right here? So it'd be 0.34 plus 0.34 gets you
68%.
Yeah. So this right here would be 0.68. All right, now the standard normal curve, okay, that has a mean of 0 and standard deviation of 1. Okay, so it's centered at 0. And let me add one standard deviation, add another, subtract a standard deviation, subtract another. Does anybody know how much area has to be under the standard normal curve between -1 and 1? Remember, it's just one standard deviation below and one above. Here, it's one standard deviation below and one above. I'll give you a hint. What do you guys think? Well, it should be the same thing. Boom. Okay, so these two, even though they're two different curves, the same proportion of area, one standard deviation below to one above, one standard deviation below to one above, has the same areas. All right, why is this so cool? Look at this chart right here, okay, that you have. All right, this right here is called standard normal probabilities. And if you look on the chart, what variable do you see right here? Do you guys see the Z? Yeah, yeah. So look, this table here gives area on the standard normal curve. If you look here, there's two sides to this table. All right, I'm going to explain how to read this table. But what I'm going to show you how to do when we get back from break is I'm going to show you how to read the standard normal area. And if you can find this area, you can find this area for any curve. So even though this is a curve centered at 20 and a standard deviation of 5, using this z-score formula, you can standardize the variable, find the corresponding area on the standard normal curve, all right? And then that area under the standard normal curve will be the same as this area here. All right, and I know it seems like a little confusing right now, but I promise you when we come back from break, I'll have this all make sense for you, okay? What do you guys think we pause for a second here? Maybe let's take a 10-minute break, all right? We'll start back up at 2:03. Does that sound okay? And if you haven't done so, come on, Matt. If you have access to a printer, I would download or print out that table. It's just going to help to read it when we get back from class. All right, so I'll be back in 10 minutes. Hey, yeah, sorry about that. Just seeing in the chat now, the table is posted. If you go under course content, under week 9, there's this thing called the standard normal table. Sorry about that in the chat. I stepped out for a second. Okay. All right, we'll get started in about a minute. I'm really sorry if this seemed confusing. I'll be honest with you, that was not my best lecture on this topic. So I'm going to try to have it be a little bit more concrete in the second half for you guys. And I promise you, as soon as we get to examples, it'll make sense. Everybody was supposed to say in the chat there, it's okay. Thank you. All right, everybody, let's get back to it. You're going to want to have this table ready for the second half of the class, okay? We're going to use it to answer a bunch of these application problems, and then after class, you will be able to do the homework by hand. So you can give it a shot and see how to do it by hand, but then also next class when we come together, I'm going to show you a little bit easier way with your calculator, which is also great. So if you want, maybe what I would suggest you do on the homework, because it's only 2 questions, is on the first question, maybe try doing it by hand like this, and then after class on Thursday, try the other one with the calculator, okay? Sound good? All right, I hope it sounds good. All right. So what we're going to do now for the next 50 minutes or 45 minutes or so is we're just going to talk about reading the table and then application problems. So if you look back at the table, okay, the table is 2 pages. Okay, do you see this little side here that has just a little area shaded here? This one here is for negative z-scores. And then if you scroll to the other page, it looks like there's so much area more shaded. This is for positive z-scores, okay? And what the table tells us, right, and I'll write this in the notes here, okay? The table gives the area to the left of any z-score, okay? It gives the total area to the left of any z-score. And so what I want to show you how to do is to use the table to find area to the left, or the area under the standard normal curve 3 different ways, okay? First, I want to show you how to find area shaded to the left of any z-score. This is the easiest one. Then I want to show you how to find area to the right, okay? And the way you find the area to the, let me go back. The way you find the area to the left is the easiest one. This method here first you can read directly from the table. The next one I'm going to show you is how to find area to the right. Well, since the table gives area to the left, it gives all the area to the left. The way you find area to the right is you just use the complement rule. All right, so to find area to the right, you just do 1 minus, you look up the value and find the area to the left. And I'll do visuals so you can see this, it's no problem. And then the next thing we're gonna do is find area between two values, okay? This last way just involves subtraction of two areas. Okay, and once you see me do a couple examples, it's a piece of cake, right? Is everybody ready if I move forward? Okay, I got one yes. All right, I got two yeses. So we'll assume we're okay. 3. Oh, thank you. Thank you. Thank you. Okay, so the first one here, I want to talk about reading the standard normal table first to find areas to the left. All right, so just this way right here. So I have two problems here, okay? The first one is I want to find the area to the left of a z-score of negative 1.25. So whenever you see the z variable or z-scores, okay, you're going to relate it to the standard normal curve. All right, and for all these problems, what I'm going to do is Matt, that's me. I'm going to use drawings to help. Okay, so to find the area to the left of a z-score of negative 1.25. So I'm going to start by drawing the standard normal distribution, okay? So because I saw the z, the standard normal distribution, it's centered at 0. Okay, here's 0. And no longer am I going to tick off standard deviations. I'm not going to go -1, -2, -3. I'm just going to say, okay, a z-score of negative 1.25 has to be below 0. It's over here. And I want to find the area to the left. Okay, I want to find this red shaded tail area here. All right, now let me ask you a question. Does this that I've drawn kind of look exactly like this curve right here? Yeah, okay, so it does. So how you read this table, it's very simple, okay? There's a column value and there's a row value, okay? So you'll notice that this first column value is only 2 digits. So it looks like -3 and then 0.4. So what you would do is you go to look at the first 2 digits over here, which is -1.2. So I'm going to go down and find -1.2. Okay, so if you're able to follow along, do you see that on your table there? Okay, yep. And then the last digit is a 5. Okay, so what you're going to do is you're going to go to the top and you're going to find the 0.05. So now what you're going to do is you're going to look where they intersect. So I'm going to go over on my curve, -1.2, and then down to 5. And what area do you guys see right there? And that's your answer right there. So the area to the left of a z-score of -1.25 is 0.1056. Was that pretty easy to read the table? Yeah, okay. All right, now let's do this next question. So now it's a little different. All right, and now I want you to find the probability that a z variable is less than 0.85. Well, just remember, the area under the curve is the probability. So whenever I see the z, I'm going to sketch the normal curve, the standard normal curve, excuse me. It's centered at 0. And this is 0.85. So that's going to be above 0. It's over here. Okay, it's just going to be above 0. And then I want to find all the area less than that. So I'm going to shade to the left. Okay, so I want to find now the probability that C is less than. Well, look, let me go back to my table. Well, this curve doesn't really look like this one, so I'm going to go to the second page. And does this curve look a little bit more like this one? With a lot more area shaded in? Yep. So whenever you have a positive z-value, you're going to use this. So again, you're going to go to the first two digits. The first two digits are 0.8. Here's 0.8. And the last digit is a 5 again. So you're just going to go over. And what area do you see right there where they intersect? Yep, you have an extra 0 in there, but yeah, it's 0.8023. And that's it. That's the area. So whenever you have a normal curve and you shade the area to the left, it's like a piece of cake. Okay, you just read it right off the table. Right? Is at least reading the table pretty straightforward? Okay, great. So now I want to talk about how you use the table to find areas to the right. Okay, so just remember from that previous slide, to find areas to the right, you're going to use the complement rule. All right, an area to the right is just equal to 1 minus the area to the left. Always, always, always. And sorry about a little bit of a typo here. Find the area to the right. Sorry about that typo. Of a z-score of 1.30. So I'm going to sketch it just so you can see exactly what's going on. Here's 0. 1.30 is out here. And I want to find to the right here. All right, so let me look up a z-score of 1.30 first so you can see exactly what's going on. So the first two digits are 1.3 and the last digit is a 0. So it's, do you guys see the value 0.9032? Okay, 0.9032. That's this unshaded area. Okay, that's all the area to the left. Now I don't want that area. Okay, so I'm looking for the remaining area. Well, the remaining area is 1. So I'm just going to, the total area under the curve is 1. So to find the remaining area, just take this away from 1. So this is just going to be 1 minus 0.9032, which if you do this in your calculator, I believe you get 0.0968. Did anybody do that in their calculator? That's the right answer, I think. All right, so it makes sense that whenever I have an area shaded to the right, it's just going to be 1 minus the area to the left.
I'm sorry, I don't see how you got the 0.9032.
Yep, no problem. I'm going to go back to the table. I'm going to look up the z-score of 1.30. So here's 1.3, and then the last digit is a 0. So it's 1.30. Does that help?
Yes, okay, thank you.
No problem. All right, let's try this next one here, okay? So I want to find the probability that a z variable is greater than 0.75. So it's centered at 0. 0.75 is over here. And then if I want to be greater than that, am I going to shade to the right or to the left? I want to be greater. I'm going to shade to the right, like this. Okay, so I want to find an area to the right now. I want to find this red shaded area. Okay, so this area here is equal to 1 minus the area I look up for this. So now I'm going to go to my table and look up 0.75. So here's 0.7. Here's 5 all the way over here. Do you guys see the value 0.7? Yep, thank you, 0.7734. So it's just 1 minus that. So if you plug this in your calculator, 1 minus this, you should get 0.2266, I believe. Does it make sense now how to find areas to the right? So areas to the left, you can just read right off the table. Areas to the right, you just have to do one extra step. So you just do 1 minus that value. It's not too bad, okay? So now what I want to show you is how you find the area between, I'm sorry, is everybody okay if I move on? So what I want to show you now is how to find area between two z-scores. Okay, now let me go back just a second. So really what you're going to do to find the area between two z-scores is you're going to have to look up both areas, and you're going to have to take away the lower area from the higher area. All right, so I'll show you this, and it's actually just really straightforward. Okay, so find the area between two z-scores. What you're going to be doing is you're going to be subtracting the two areas. Okay, so I want to find the area between z is equal to 0.25 and z is equal to 1.25. So I'm going to sketch it. So you're centered at 0. 0.25 is over here. 1.25 is over here. So I want to find the area between them. Okay, so the first thing you do is you go look up the higher z-score. Okay, so we're going to go look up this 1.25. So I'm going to go to 1.2. And I'm going to go over to 5. What area do you see there? Do you see, well, so 1.25. That's okay. That's why we do these examples. Yeah, you looked at 0.25. So 1.25, it looks like that's okay. Yep, it's 0.8944. Right, so just so we're clear, that's the area from here all the way this way. So I don't care about this unshaded area here. So let me look up 0.25, which you actually did for us. So 0.2 is the first digit. 5 is the last digit. That's where you get the 0.5987, okay? So that's this unshaded area. Well, since I don't want it, I have to take it away from this one. So this area is just the higher area minus the lower area. And I'm just curious, can anybody do that in their calculator for me? I'll do it too here. 0.8944 minus 0.5987. Yep, thank you. 0.2957. Pretty straightforward. All right, let's just do this last one. So I want to find the probability of z is between negative 0.55 and 0.35. So you're centered at 0. 0.35 is over here. Minus 0.55 is down here. And I want to find this area between them. All right, so you're going to look up the higher z-score first. Okay, so you're going to look up this 0.35. So here's 0.3 is the first two digits. The 5 is over here, so 0.35. You should get 0.6368. And you're going to subtract away. You're going to go look up this negative one, negative 0.55. So you're going to have to go to the negative side. Negative 0.5, and then you're going to go over to 5. I think you get 0.2912. Anybody else agree with that? All right. So if you just grab your trusty calculator and plug those in. I think you get 0.3456. Ah, that's funny. 3456. Okay. Does it make sense how to read the table? Are we good on that? Do we think? Okay. Now we're ready to answer that iPhone example. All right, so here's how we're going to answer these application problems. So we're going to go back to that iPhone example. All right. So here was the problem. Suppose talk time on the iPhone 10 is normally distributed with a mean of 20 hours and standard deviation of 5 hours. An iPhone 10 is selected at random and its talk time is recorded. So we got the random variable X. What is the probability that the talk time on an iPhone 10 is less than 18 hours? So if you just pay attention to this, how I'm going to do this example, okay? This is honestly how your homework is done. So you can legit do your homework immediately after this, okay? So what I want to do is I'm going to go through the steps with you here, right, while answering that question, okay? So I'm going to rewrite it over here. All right, so the first thing you're going to do is you're going to identify the variable you're working with and you're going to write the probability statement, okay? So going over here, what is the probability that the talk time on a randomly selected iPhone 10 is less than 18 hours? So step one, all right, you're going to identify variable and write probability statement. So all right, so here's what was going on. I'm going to let X be equal to the talk time on a random iPhone 10. Okay, that's identify the variable. And then the probability statement was, I want to find the probability that it's less than 18 hours. Okay. Is everybody okay if I go back for a second just to get to step 2? All right. I really find that this helps. For as long as I have been doing these problems, okay, after we do a bunch of examples, everyone will see that this stuff is super straightforward. 9 times out of 10 when somebody makes a mistake, it's because they didn't do step 2 and they actually found the wrong area. So step 2 says draw the normal density curve and shade in the area corresponding to the probability statement in step 1. Okay, so the second step. Is you're going to sketch the normal curve related to the problem. All right, so what I'm going to draw here is I'm going to draw the iPhone talk time. Okay. So the mean was 20 hours, okay? So I'm going to put 20 here, and then I want to be less than 18. So I'm going to go over to 18. And am I going to shade to the left or to the right if I want to be less than 18? Yep, I'm going to shade here to the left. The third step you're going to need to do is you're going to need to compute z-scores as needed, okay? So you're going to need to do z-scores for values of interest. And basically what that means is whatever value you have in the probability statement, you need to compute z-scores for, okay? So the z-score formula, it's always the variable minus the mean divided by the standard deviation. Okay, so it's x minus the mean divided by sigma. This is my x variable, okay? So you see the x here in the formula? I'm going to put 18. What was the mean talk time? Okay. What was the standard deviation? All right. So 18 minus 20 is minus 2. Minus 2 divided by 5, I believe, gets you minus 0.40. This is so cool. Do you guys like see what's going on here? Like I'm looking for an area to the left and I've got the corresponding z-score for that. So like the final step, step 4, use the standard normal table to find the corresponding area. So the final step here, use the standard normal table. So my original problem was this. What's the probability x is less than 18? Well, its equivalent statement is what's the probability that a z-score, because I'm changing 18 to a z-score now, is less than minus 0.40. Well, look, I'm looking for an area to the left. I know the z-score. So I'm going to go to negative 0.40, and we got it. Alyssa has it right in the chat. Negative 0.4. The last digit is 0. and you get 0.3446. So that's the answer. What do you think? A little bit easier than the way we were doing it before, or not easier? I have one easier. Like, what I love about this method here is like, just follow these steps. Boom, boom, boom. You'll get it right every time. Boom, boom, boom. How I got this, how I looked it up on the chart. Is that what you're asking me? Yeah, okay. So do you see the z-score is negative 0.40? Do you see that? And I'm looking for the area to the left. So the table gives the area to the left. So the first thing I look at is the first two digits, which is negative 0.4. The last digit, excuse me, is a 0. So the last digit here is a 0. And I look where they intersect, and I get 0.3446. Got it? All right, how about we do two more examples? Sticking with the iPhone stuff. All right, just so you can see, I'm going to ask an area to the right and then an area between now. All right, how about that? Sound good? And then that'll take us right to the end of class.
I actually have a question.
Yeah.
Relating to something that we did before this iPhone example.
Sure.
It was the one with area between two z-scores.
Yeah.
So the last one that we did, I'm not sure. So for z is greater than negative 0.55, how did you get 0.2912? Because isn't that shaded portion to the right?
Yeah. So, no, so you probably looked up. I'm not sure, but if you look up negative 0.55, like, do you see my table right here?
Mm-hmm.
Here's negative 0.5. And then the last digit is a 5.
Yeah, but isn't this table referring to values on the left of that number?
It does. So what's really happening here is, do you notice how I'm like not interested in this area right here? So this white open area here is 0.2912. And this 0.6368 is the area from here all the way here, which includes this unshaded area. So I have to take it away.
Oh, okay. Got it.
Does it make sense? Okay.
All right, thank you.
Will we be working on those problems on our own? The one we are getting? I don't know what you mean by that. Is it okay if I just walk you through the next two so you can see exactly how they're done, and then you'll have a chance to do, practice on your homework? Does that sound okay? In the chat? Yeah, just because I want to make sure we got them before we run out of time, okay? Because I only got 15 minutes left. Okay. So the reason this first one took me so long is because I had to explain all the steps. But what you'll notice now is after you see me do the next two, you'll see that it goes really, really quickly, okay? All right, so watch. What is the probability the talk time on a randomly selected iPhone 10 is more than 24 hours? Okay, so the first step, step one. We already wrote the variable. So I want to now find the probability that X is greater than 24 hours, okay? So I could talk to somebody for an entire day. Step two, okay, what I think really helps, right? What did I say I think really helps? And that 9 times out of 10, if you skip this step, it doesn't help.
Drawing out the curve.
Sketch the curve, trust me. Okay, it takes 2 seconds and it's worth it. All right, so iPhone talk time is this bell curve. Whoosh. It's centered at 20. And I want to be greater than 24. So 24 is out here. And I want to be greater. So am I going to shade if I want to be greater to the right or to the left?
Right.
Yep. All right, step 3 is z-scores. I only need one z-score, okay? Because there's only one value in here. All right, so my z-score formula is x minus the mean divided by the standard deviation, which is 24. What was the average talk time again? Yeah, what was the standard deviation? So this becomes 4 divided by 5, which is 0.80. Then finally, step 4. Probability that x is greater than 24 hours is now the same exact thing as the probability that a z-score is greater than 0.80. And this is why I say sketch the curve. All right, how do I find an area to the right? Comp rule. Yep, so it's 1 minus. You're going to look up 0.80. So you have to go to the positive side. Yep, 0.8, and the 0 is right here. Yep, thank you very much. So it's 1 minus 0.7881. And I believe that gets you 0.2119. Did I do that correctly in my head? Thank you. So what do you guys think? Like now having me seen doing a second example, do you guys see how like, let me ask this, does it make sense how we do these problems? Okay, is it a lot easier than before? Yeah, you know what I noticed, like, and I'll be honest with you, for as long as I've been teaching this, like when I try to explain the concepts, it's like, what is going on? You know, but then as soon as you see the first example, it's kind of like, oh my gosh, okay, I get it. I get it. All right, let's do this last one, okay? What is the probability the talk time on a randomly selected iPhone 10 is between 17 and 21 hours? So it's the probability that this talk time is between 17 and 21 hours. Okay, so I'm going to sketch the curve. You're going to be centered at 20. 17 is over here. 21 is here. And I want to find between. All right, for this problem here, how many z-scores am I going to need to compute though? Yeah, unfortunately you're going to have to do for 17 and for 21. Okay, so I'll start with the z-score for 17. So in this case, it's 17 minus 20 divided by 5, which gets you minus 3 divided by 5, which gets you minus 0.60. And then I need to do the z-score for 21. Which would be 21 minus 20 divided by 5, which gets you 1 divided by 5, which gets you 0.20. And then your last statement here, the last thing you need to do. So the probability that it was between 17 and 21 hours is now the same thing that a z-score is between negative 0.60 and 0.20. Well, I forgot. How do you find an area between two numbers? Yep, you got to look up the areas and subtract them. Yep. So you start by looking up the higher z-score. So that's 0.20. So first two digits are 0.2, last digit, so it's 0.5793. Minus, now I'm going to go look up negative 0.60, so I'm going to have to go to the negative side. So here's negative 0.6, and then here's the 0, so it's 0.2743. And if you do that quickly in your calculator, I'm actually using my phone for these simple ones. Do you get 0.3050? All right. What'd you guys think? What a lecture. We learned how to read a table. We had a screaming child through half the lecture. You know, I'm going to ground my son. All right. I tried telling him to be quiet during class, but he doesn't listen. Yeah. Sorry, guys. He's teething, so he's going through a tough spot. All right. I'm going to stop the recording.